All right, we're going to do a little warm-up for a logs quiz that we're having today. First question, if you see this, what's the answer? 5. Because if these two are the same, then that's the answer. How could I figure it out? Well, I actually could say equals any letter. I usually use x, but since I already have an x in the problem, I'm going to say q. And then I could rewrite it and say x to the q is equal to, see it goes over here, and then comes back over here, x to the 5, and you can see that q, the answer, must be 5. All right. How about this one? Log base 3.7 of 1. We had this on a test, and some of the kids, I remember saying, you can't do that without a calculator. Yes, you can. What's the answer? 0. What if you were trying to figure this out and you were stuck? What should you do? You say equals x, and then you say 3.7 to the x equals 1. Good. So then you'd ask yourself, what could I put here to make it equal 1? The answer has to be 0. Otherwise, you can just memorize the property that if there's a 1 right there in that spot, then the answer has to be 0 no matter what. All right, next one. ln. What's the answer? 1. Because this is really log base e of e, and then the answer is the exponent, which is right there, which is a 1. Okay. Next one. What if I had log of x plus log of 7? Log of, not minus, 7x, or x times 7. All right. Another combining one. Log of m minus log of p. That'd be log of what? M over p. All right. Those are just little basics that you can use to solve harder problems. What happens if you have something that's like 9 to the x minus 4 is equal to 12? What form is this in? This is an exponential form. You've got to rewrite it as a log. Log base 9 of 12 equals. And if I only knew what that was, I'd be able to get it. Okay? And those should be numbers that are nice enough that you can do it without a calculator, because on the test, you're not allowed to use calculators. This will be about as tough as it gets. So you need to be able to rewrite that 1/3 as a 9 to the something. Got to be able to rewrite the 1/3 as a 9. 1/3 is 9 to the what is the question. Do you get that you need to take a 9 and make it smaller so that it becomes a 3? -1/2 is the latest theory. Let's see if you're right. Well, to do this, I ignore the negative for a second. What's 9 to the 1/2? 3. And then you do the negative, and that makes it 1/3. Yes. So 9 to the -1/2 works. Why did I want to put a 9 to the -1/2 there? Because now this is the same as this, and so the answer over here is this. So the whole left side just becomes -1/2 equals x minus 4, and then I just add 4 to both sides, and I got my answer. Okay. Now, little 5-question quiz. Find a blank sheet of paper, number it from 1 to 5. Leave yourself, like, go all the way down the whole page. So leave yourself like 4 lines for each problem. 1, 2, 3, 4, 5, all the way down the page. And you're going to have somebody else grade this. Do it as if it was an 85% category test. It's not, but act like it is. And I need to tweak one of my problems that I was planning on giving you here, because you'd have to use a calculator to get the answer on one of these. So I'm going to tweak it. Let me see if the first one is that one. Yeah, it is one of them. So why don't you start on number 2 and leave room for number 1. I'm going to change number 1, but start on number 2. Number 1, if I change it to change this to a 32. Then I think, yes, now it's doable without a calculator. This is, number 5 is just testing on whether or not you remember how to solve a quadratic. I just realized number 3 you'd have to have a calculator also to be able to do it, so I'm going to simplify it for you. ln e to the, let me think. Yeah, there we go. Now number 3 doesn't need a calc either. Okay, there. This is all doable without a calculator. And it's great practice for the test that's coming. Keep in mind the test isn't until Tuesday of next week, so you got some time. I'm going to hit pause while you work on this little mini quiz. Yes, 3 is doable now. You do not need a calc for that. All right, so I'm going to just do each problem for you so you can see how they would be done. I want you to be looking up here so that you can watch and see if you did it this way. Divide by 2, divide by 2. You can't start this problem without getting rid of the 2. If you try to do the log first, you'll fail. So this cancels, and this becomes 1/4 to the x over 2 is equal to 16. Now I can do the log thing. Log base 1/4 of 16 equals x over 2. I rewrote this exponential as a log. This to the this equals that. No, wait, log of this. Sorry. I wrote it as a log, not an exponential. Okay, so there it is. Now, here's the hard part. Can you rewrite 16 as 1/4 to the something? Because if you can't, you probably got this one wrong. 16 could be written as 1/4 to the -2, right? Because 1/4 to the negative second power means 1/4 to the second power. Sorry, not negative 1/4. 1/4 to the second power, and then you flip it, which would be 1/16, and then you flip it and it'd be 16. So yes, that works. So then why is that good? Because these two are the same as each other, so then the answer is -2 equals x over 2, and then you multiply by 2 on both sides. -4 is your answer. I'm curious how many people had to mark that one wrong because your person goofed it up. Okay, good. Not many. Next one. Number 2. This can be put together, and I'd say log of 2x, or x2, but 2x makes more sense, equals log of 28. When these two are the same base, they both are a log base 10, I can just drop them. And then I get 2x equals 28. And then x must equal 14. Now some of you did that a way harder way, but it probably could have come out to the same answer. But how many of you, no, this is like a R2, maybe an R3 level question. Oh, I'm sorry, I thought you were asking if this was an R4 level question. Number 2, how many of you had to mark this one wrong for your person? Only a couple, 3, 4, okay. Moving on. This one. I hope you recognized that this right here was really equal to what? 5. And that this right here is just a property again. What's that equal to? So x equals 5. Done. Because if this and this are the same, then that's the answer. That's a property. Yes?
I thought that the 8, I didn't think it was to the log was,
You...
log. I thought it was like 8 times log, so I moved the 8 over the x, and so I got like
a totally different answer.
Yeah.
Gotcha. Is there anybody else that thought this was an 8 in front of the log? Okay, I will do an alternative answer then for those people. Let's say for a second that this had said 8 log base 8 of x. Then what would I do? Then my next step would be divide by 8 on both sides to get rid of that 8. Okay, and then I would have 5/8 equals log base 8 of x. And then I would have rewritten this as 8 to the power of 5/8, good luck doing that, equals x. If you had 8 to the 5/8 power, you can have credit. Didn't think you probably did. If you did, then I'll take it.
No, I moved 8 to the x, so I did x to the power of 8.
Okay, well, that's what you should have done if you had thought that that's what the problem was. So anyway, let's move on. Are we on 4? Okay. Expanding it. ln of 2x, and this divide right here should turn into a minus. ln of e. Did anybody notice that ln of e is just sitting there waiting to be fixed? What do you turn it into? 1. So it's ln of 2x minus 1. And then the ln of 2x can expand into ln of 2 plus ln of x. Then I have the minus 1 at the end still, and there I am. They can have half off if they forgot the ln e thing and had everything else right. And yes, at the end, the half's around the nice way. What? Do you need parentheses? No, because if I put parentheses in here, it really won't make any difference. It would be allowed, but not required. Now, if there'd been 2 parts to the ending, the minus, you know what I mean? If there'd been like 2 parts here, then I would have had to have parentheses. Because the only reason you really need the parentheses is if you have to distribute a negative like that. So, but in this problem, we did not need parentheses. Yes? If the only thing that's wrong is they have an ln e right here, they can have half off instead of a whole off. Okay? And the reason that's going to help is that at the end, if it's out of 5 points thinking that then they only have a half wrong, it's going to round the nice way. Moving. Okay, I'm curious on that one. How many of you had to mark this one wrong for your person? At least a half wrong on it. Okay. On to the next one. And that was only about 4 people out of the class, by the way. This one, you should have noticed it's a quadratic. We talked about these yesterday as a reminder. X squared plus 7x minus, no, plus 6 equals 0. See, I moved it over to the other side. And now I can factor it. And if you wanted to use quadratic formula, that'd work fine. But I'd use this. And then I'd have x equals negative 1 and x equals negative 6. Okay, what if they have one of the 2 answers wrong? Take off half. Yes, in the back. On number 1, could you do what? Are you saying you think negative 1 works? I don't understand. Did your person have the answer of x equals negative 1? Okay. And are you asking if that's really right? Okay. I can tell you it's not right, but I can try it by sticking in a negative 1 here. Then that's going to take that and square it, and it would be 16, and I would flip it, and I'd have 32, and I'd have 2 times 32 equals 32. They were close, but it wouldn't work. Do you understand what I'm saying? If I put in a negative 1 right here, then I'd end up with negative 1/2, which means I take the square root of 1/4, which is 1/2, and then I flip it, which makes it 2. Actually, no, it'd be 2 times 2 is... You would be saying 2 times 2 equals 32, and that doesn't work. Either way, it doesn't work. So bottom line is, I gave you the right answer for number 1. It was negative 4. Okay, get it back to the owner. I'm curious how many of you, personally, with your own paper, have a score that you would be okay with on the test. Well, that's a good sign. All right. That's more than half the class. All right, now if that did not go so well, you need to understand what you did wrong and learn from it. We have a week almost between now and when we take this test. But if you don't take the time to figure it out, you don't come in the mornings and get help. You're just saying that I'm lost and I don't care. That's not good. If you care, you can get help. All right, so our homework for tonight has a few tricky things I want to talk to you about ahead of time so you don't have to struggle with it for too long. On the worksheets I gave you, one of them has got this kind of thing set up. It's not exactly this, but it's like this. Do you get that if these had the same base, that it'd be really an easy problem? You just set that equal to that and solve it? Okay, but they don't have the same base. But how could I make them so they did have the same base? I could rewrite this one as 5 to the what? Yeah, I could write this as 5 to the negative 1. And then I'd put it to the 2x equals 5 to the x minus 4. All I did was replace with a 1/5 with a 5 to the negative 1. You get that? All right, so here's a tougher one. Let's say that you had these two bases, 1/4 and 16 as your two bases. Well, that one's not too bad. I could rewrite the 1/4 as 16 to the negative 1/2. All right, but what happens if you need to make it like 32? On the last one, you mean? Or? Okay, okay. So let's just do the beginning of this problem together because so many people got stuck on it. I'll tell you which one it is. Find the worksheet I just gave you, and it's number, on the one that doesn't have a back side, the one called worksheet number 1, it is letter I. Would you read me letter I off, not that one, but the other one? That one. Letter I. All right. Now, this is one of those kind I was just talking about. This is definitely a tough one. I got to rewrite that 8 as a 1/4 to the something. Or I got to rewrite the 1/4 as an 8 to the something. Either way would work. How about this? I think it's easier to take the 8 and do stuff to it. So let's rewrite the 8 as 1/4 to the something. 1/4 to the what would make an 8? Yes?
I just wondering, could you make them both bases?
Yes, you absolutely could. That would be a good way to do it. In fact, that might be easier. But I'm going to try to make sure you get how to make something like have a tough exponent. All right. So if I want to make this 1/4 grow up to be an 8, you can't make it a 2 because otherwise you're going to end up making it into a 4 squared is a 16, and that went past what I wanted. So it's kind of a tricky one. You have to make it smaller before you make it bigger. You're warm. -3/2 is right. Here's why. Because that's three things. That's making it smaller before you make it bigger, and then you gotta flip it. What's 1/4 to the 1/2 power? That means the square root of 1/4. It's a half. What's a half cubed? An eighth. What's an eighth flipped? It's an 8. All right, so that was an intense one. So what that's saying is I can rewrite an 8 as a 1/4 to the -3/2. Then I can put that right here. I can put a 1/4 to the -3/2 right there. But somebody just a second ago said, couldn't you change both of their bases to be 2 base 2? And I really like that idea. I think it's going to be the easier way to go. All right, so if we rewrite this 1/4 as a 2 to the something, what would it be? 2 to the what would make 1/4? First you got to make it get bigger so it's a 4. How do I make it into a 1/4 now? There you go. So I'm going to rewrite that as a 2 to the negative 2, and then leave the power the same as it was, equals that 8. I could write it as 2 to the what? 2 to the 3rd. And now they're both in base 2. So this is a good way to do letter I off the worksheet called logs worksheet number 1. And then from here, the bases are the same, so that has to equal that. So I just multiply them out. Negative 2 times x minus 1 will equal 3 times 2x minus 1. And from there it'll be easy. Okay? So there's a couple different ways you can solve that problem. I'll leave that one up on the board for you. That was probably one of the toughest ones you have on the worksheet. A lot of the other ones are like super easy. Alright? If you get stuck, I'm up here, willing to help you. You just come up one by one, you can sit in the chair, ask for some help while you're working on this worksheet.